Okie dokie. So you guys had some homework. Now, some of the homework problems were pretty challenging. That's true. These are the basic type of problems. There's not a whole lot of lines and it's just triangles. But when you start having lines and parallel lines, it can get a little involved. So as I've been doing, I just uploaded the pictures, so it would be a more manageable file size for you guys. Okay, and I pretty much did the homework for you. Now, some of this I just said solve. I didn't finish it. Okay, so you got everything you need here, and I'm just going to point out a couple things since me writing what I did here is pretty much sufficient, I think, for you to get help. All right. Now, of course, if you want me to verbally go over a specific problem, let me know. Okay, so again, once you see the two angles are congruent, that means it's isosceles. Okay, and then this could have been tricky because even though we've done problems where we dropped an altitude, which makes a right angle with the other side, that's the same thing as the angle bisector, which is these two little curve markings being the same. And so that implies this has to be isosceles, right? And that's just some of the tricky things about geometry, realizing that. Once you realize that, you can see it's really easy. X is the same as 6, X is the same as 4. Okay, and the same thing here. Since it's isosceles, then the two angles on the bottom are the same. Now, if you're looking for the angle that's different, the angle that's in between the two congruent sides, then you got to do some math relating to 180. Right? So you can just subtract the other two from 180 or solve this equation. Right? And then 9 and 10, that's when it started to get a little tricky. Right? And this is where we've got to use vertical angles, because the only way we're going to get an angle in the bottom triangle is by finding the angle in the top triangle that's different than the 265s. Again, that's the math that I'm doing here. Again, the same thing here. In order to get an angle in the top triangle, you're going to have to subtract the 28 from 90. And then now you know in the top triangle, those two are both 62. And so then you could solve this equation to find x. Okay, very similar problem here, except the 148 is exterior to the triangle. So you got to do 180 minus 148 to get the 32 here. And then you subtract 32 from the 90. And in the top triangle, that means both of these are 58 because it's isosceles. And then since the x is actually exterior, then you got to subtract from 180. So the math in itself is not demanding. It's interpreting the geometry that's a challenge. That's the tough part. And the only way to get better with these is to do some practice problems. That's really it. Now, this was interesting, number 12, because again, to get the angle in the triangle, since 120 is exterior, you subtract from 180. Again, that's a straight line. And since that's 60, then the other two have to be 60, because when you divide what's left from the 180 by 2, 180 minus 60 is 120. 120 divided by 2 is 60. So this is actually an equilateral triangle based upon what happened when you got the interior angles. And then you can use the vertical angle over here to get the 60, which means that has to be 60 because, again, isosceles. And then now you find the value of x. And I just put a box there because I wanted you to figure out that that was 62. I just did right 60. And then 13, again, this is probably tricky because, we're just getting basic geometry and we may not know anything about proportional relationships right now, but these angles are all one. So they're the same. So we've got two triangles that have the same two angles. That means the third one's the same. Now that doesn't guarantee congruence. You can have two triangles that have all three angles the same. They could be completely different. One could be bigger than the other. As soon as you know one side is the same, that means they're congruent. So because these have the same side, in addition to two angles the same, which implies the third angle the same, and that's kind of what I'm writing here. So then we can solve the equation because those two sides are congruent. And perpendicular bisector, same thing. Once you know this is a bisector because the two angles are the same, you already knew the two sides were the same. So if we draw a altitude, that means make a right angle, that is a perpendicular bisector. So that's why 12 and 2x minus 12 are equal. Okay, and very similar to some of the other problems.